Hi everyone, and thank you for tuning in to this lesson from S.Success Tuition. This lesson is all about fractions and the four operations. If you have any questions, please feel free to email me. Good luck! So multiplying fractions is one of the easier operations to do with fractions. So a lot of people get very confused because there are different methods, one for add and subtract, one for times and one for divide. Now multiplying is probably the easiest method because all we do is we simply multiply through our fractions. So for example here, we multiply the two numerators together, 2 times 4, and we multiply the two denominators together, 3 times 5. So 2/3 times 4/5 ends up being 8/15. And it's as simple as that. So with this one, we'll do 7 times 3 and 9 times 5. So we get 21 over 45. Now we encounter a bit of a problem with the last two because we have whole numbers. But a really simple fix is that any whole number just goes over 1. So if you just pop a 1 underneath your whole number, we can then do exactly the same again. 3 times 1 and 1 times 9, which ends up as 3/9. And 3 times 12 over 4 times 1, which is 36 over 4. Now, as always, we should always check our answers to see if we can simplify or cancel down our fractions. A lot of the time in a test, you'll be asked to leave your fraction in what is known as its simplest form. So, with the first one, 8/15, 8 and 15 have no common factors. So there's nothing that I can divide them both by. So that would stay like that. Now 21 and 45 are both divisible by 3. So in order to write this one in its simplest form, I'm going to divide the top by 3. So 21 divided by 3 is 7. And then I'm going to divide 45 by 3. Now don't forget, if you don't know what 45 divided by 3 is off the top of your head, you can do a little bus stop division to work that out. So it would be 15. So 21 over 45 is equivalent to 7 over 15. Now 7 and 15 have no other factors in common, so that would stay like that. So with this fraction again, I can see that I could divide the numerator and the denominator by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. So 3/9 in its simplest form is 1/3. Now you'll notice this one is a little bit different to the other ones we've done. All of our answers for the three above are what we would probably consider as proper fractions. A proper fraction is something that is bigger on the bottom than it is the top. Now in this case we have a bigger numerator. So these fractions are called improper fractions. Now an improper fraction is actually something that is bigger than one whole. So what we would normally do is see how many times the denominator, the number on the bottom, goes into the numerator, the number on the top. Now in this case, 4 goes into 36 a whole number of times. So 36 divided by 4 is just 9. So this fraction, this multiplication here, actually ends up being a whole number, which is just 9. That won't always be the case, but in this case, 36 divided by 4 gives us 9 wholes. On the next slide, there are a number of questions for you to try. Pause this lesson and try them. When you're finished, press play to reveal the answers. Remember to pause here because the answers are coming up shortly. Okay, so now this slide is going to go through the answers. So if you've not finished, just pause this video and go back and answer the questions. Remember to cancel them down if you can, as this will usually get us an extra mark. Okay, so for this first question then, we have a whole number, 20. Remember, put any whole number over 1. And then we multiply the tops. 2 times 20 is 40. 3 times 1 is 3. Now again, we've ended up with an improper fraction here. Remember, an improper fraction is where it's bigger on the top than it is the bottom. Now this means that this answer is bigger than one whole. So what we would do, we would see how many times 3 goes into 40. Now 3 goes into 40 13 times, because 3 times 13 is 39. So if we get to 39, we actually got 1 left over to make the 40, so a remainder of 1. Now that remainder goes back over the 3. So if you were asked to leave your answer as a mixed number, you would write it as 13 1/3. So with the second one, 3 times 10 is 30, 5 times 11 is 55. And again, we always check to see if we have any common factors. Now I can see that 5 is a factor of both 30 and 55. So I'll divide the top and the bottom by 5. 30 divided by 5 is 6, and 55 divided by 5 is 11. And that there is in its simplest form, 6/11. Again, we have a whole number on number 3. So 3 times 2 is 6. 1 times 15 is 15. This can also be simplified. 3 is a common factor, so divide the top by 3 and divide the bottom by 3 to get 2/5. Finally then, for our last question, 2 times 4 is 8, 9 times 11 is 99. Now for this question, there are no common factors, so that would stay as 8/99. Well done everybody. The next part of this lesson teaches you how to divide fractions. What's really strange about dividing fractions is that we never actually do a division, so you will never divide anything with this skill. Instead, we turn it into a multiplication. Now what I want you to do is whenever you get a divide with 2 fractions is put a cross, and quite a big cross, through the divide. Now that's going to tell you 3 things. The first thing it's going to remind you we're not dividing, so we've got rid of the divide sign. Instead, we've turned it into a multiply. And then the cross also shows you which numbers you multiply. Now what I recommend is that you keep your first fraction like that. And then when you show your workings, you won't forget which thing needs to be at the top and which needs to be at the bottom, because that's really important. So on the top, we do 3 times by 5. And on the bottom, we do 11 times by 4. So what we actually have done is we've multiplied across the diagonals, and we've ended up with 15/44. So let's look at the next question. Remember, anytime you have a whole number, pop it over 1. And then we see that we've got a divide. And we need to remember we do not divide fractions. So we're going to cross that out. So I'm going to multiply instead, keeping that first fraction 4/1 as it was. And then I'm going to multiply across the diagonals. 4 times 3 and 1 times 2. And so I got 12/2. Remember, as always, you will probably ask to leave your fraction in its simplest form or to cancel it down. So how many 2's go into 12 would be 6. There's nothing left over, so this one was actually 6 wholes. Same again on the next one. Multiply 5 by 4 and 6 by 3. So we get 20/18. Now I can see that I can first of all simplify this, so cancel it down by halving it. If I half it, I've then got 10/9. However, it's still improper, so if you're asked to convert it into a mixed number, we'd see how many times 9 goes into 10. 9 goes into 10 once, and there's 1 left over, so that remainder 1 goes back over the same denominator. So the last question then, we're going to put the whole number over 1. Because it's a divide, we're going to cancel it out and change it to a multiply. Keep my first fraction 2/5 in the place that it was, and multiply across the diagonals. 2 times 1 and 5 times 10. So we end up with 2/50. In order to leave that in its simplest form, I can divide the top and the bottom by 2 to leave me with 1/25. So on the next slide, I am going to give you some questions which teaches you, or which will allow you to practice this skill. So when the slide comes up with the questions on, if you pause the slide and then answer the questions, you can then press play again and then there will be worked answers. Good luck. Okay, so there are a few questions coming up on dividing fractions. Don't forget to pause the lesson to give you time to answer them. Okay, so I'm now going to go through these answers. So if you've not finished, make sure you pause this now and finish the questions. Okay, so they're all divide. And remember what we said in the previous lesson, we multiply across the diagonals. So we do 2 times 5 and 9 times 3. So your answer and your final answer would have been 10 over 27. So for the next one, on the top you would have done 4 times 3, and on the bottom 7 times 2. So you would have ended up with 12 over 14. Now this one here can be simplified, so it will cancel down to 6 over 7. With this next one, again, same again, but any whole number, remember, goes over 1. So pop that 10 over 1 and then do your multiplication. So we end up with this one with 6 over 70. This one here can be cancelled down, so it will be 3 over 35. And then the next question, again, times across the diagonals. So we do 1 times 3 and 4 times 2. So we get 3 over 8. And for the final question, we do 7 times 4 and 1 times 1. So we get 28 over 1. Remember, 28 over 1 ends up being 28 wholes. So well done. If you've managed to get all of those questions correct, then that's really, really good. Don't forget, you can go back and redo this lesson if you've got some of them wrong, just to recap your memory. Okay, so next up we're going to be looking at how we add and subtract fractions. The next part of this lesson teaches you how to add and subtract fractions. Now, in order for us to add and subtract fractions, we need to have a common denominator, which means the same number on the bottom. If we have a common denominator, then we're really lucky. So students in probably years 5, 6, 7 and 8 may get some questions where you have the same number on the bottom, but other years probably not so much. So when we do have a common denominator, we're really lucky because we don't have to change anything, and we only do the operation, in this case the addition, to the top. So 2 plus 1 is 3. We do not do this to the denominator. The denominator stays the same. As always, if we can cancel down our fraction, then we should. So this one here can be divided by 3 on the top and the bottom to leave us with 1/3. So looking at the next fraction. So again, the same rule applies for subtraction. We need a common denominator, which we're very lucky we have. So again, we only do the sum for take away 2 to the top. The bottom stays the same. On these last two questions, you'll notice that we have a different denominator in each fraction. This means we have to do a little bit more work than what we had to do up here. Now what I suggest is that you always look at the fraction with a smaller denominator. So in this case, the 4 is smaller than the 20. Now what we should do is we should think, right, can I multiply 4 by anything to make it 20? And we can multiply it by 5. If I multiply the bottom by 5, I have to do it to the top in order to make it an equivalent fraction. If you don't do it to the top, you've changed the fraction completely, so you have to do it to both. So by doing so, I get 15 as my numerator and 20 as my denominator. So I've now got an equivalent fraction, but that equivalent fraction is much more helpful for me because I now have a common denominator. So we can simply add the tops and pop the 20 on the bottom. Now this answer here can be divided by 4. 4 goes into 16 4 times and 4 goes into 20 5 times. Looking at our last question then. I said to you before to look at the one with the smallest denominator, which in this case is the 2. What can I do to 2 to make it 10? And I can times it by 5. Again, doing the same to the top. Now the first fraction here then doesn't change, that was still 9 over 10, so we were happy with that one. And what we then did was we changed this one here to be 5 over 10, so it's still equivalent to a half, it still means a half, it's just written in a different format. And the reason why we wrote it that way is so that we can then do the subtraction. We've got a common denominator, so we now don't need to do anything to the bottom, and we just subtract the tops. 9 take away 5 is 4. Again, we can cancel this one down by halving to get 2/5. Okay, so I'm now going to go through the answers to these questions. So if you haven't finished them, then just pause the video and finish them now. Okay, so we have 3/7 plus 2/7. We're lucky enough here to have the same denominator, known as a common denominator, so we don't have to change any of the fractions, and we simply just add the tops together. 3 plus 2 is 5, so we get 5/7. On the next question, we have a different denominator. So what that means is we have to find a common denominator. So 5 is the smaller out of the 2. So I'm going to look and I can see that I can times 5 by 2 to make it 10. So 9/10 take away my new fraction, which is 6 over 10. 3 times 2 is 6, 5 times 2 is 10. So I've just found an equivalent fraction which will allow me to do the actual subtraction. So 9/10 take away 6/10 will leave me with 3/10. Okay, on the next question, 4/9 add 13/90. Again, we don't have the same denominator, so we're going to need to change one of them in order to make the other. So I can see here, if I times 9 by 10, I'll get the 90. As always, doing the same to the top so that we don't actually change the value of the fraction. So this first fraction now becomes 40 over 90. So then plus the 13 over 90, which gives us 53 over 90. None of these at the moment can be simplified, but remember we should always be checking for that. Okay, and the last one then, I can see that I can multiply 5 by 6 to make the 30. So if I multiply the top and the bottom by 6, I get 24 over 30. Then I'm able to take away the 7 over 30 because we have a common denominator. So 24 take away 7 is 17. So the next part of this video is going to teach you again how to add and subtract fractions, but this time where the fractions are a little bit more complicated and where we cannot just change one of the fractions. So in the next video we're going to have to change both of the fractions. Okay, so this part of the lesson here is still to do with adding and subtracting fractions. As we said in the last part of the lesson, we need the same denominator in order to add and subtract. Now, we looked at questions where we didn't need to change the denominator at all, and then we looked at some questions where we needed to change one of our fractions. Now, what you'll notice about, say, this first question is, like I mentioned in the last sort of part of the lesson, we should always look at the smaller denominator, so the 3. Now, can we multiply 3 by anything to make 4? Now, in this case, we can't. So when you cannot do that method, you have to change both fractions. So what I'm going to do is I'm going to teach you a method that will work for all of them. If you have to change both fractions, if you multiply the first fraction by the second denominator, so in this case the 4, again remember whatever we do to the bottom we have to do to the top. We then multiply the second fraction by the first denominator, so in this case the 3. So what you'll notice we have is 3 times 4 and 4 times 3. Now of course we know that when we multiply it doesn't matter which order we do it in, so 3 times 4 and 4 times 3 is the exact same sum. So by doing so we end up with a common denominator. 2 times 4 is 8, 3 times 4 is 12, that's your first one. Your second one, 1 times 3 is 3, 4 times 3 is 12. So you can see that now I've changed both of my fractions, I now have a common denominator. And remember, we only do the sum to the top, so 8 take away 3 is 5. So our final answer is 5/12. Okay, question 2. Look at the smaller fraction, 9. Can I do anything to 9 to multiply it up to make 10? No. Okay, so again, we're going to have to multiply and change both fractions. I do that by multiplying the first fraction by the second denominator, the 10, and I multiply the second fraction by the first denominator, which is the 9. So 7 times 10 is 70, 9 times 10 is 90, 1 times 9 is 9, 10 times 9 is 90. So again, we've achieved what we needed to, and we now have a common denominator of 90. We then just add the top. 70 add 9 is 79. Okay, so the next one, we look at the 2. Can we multiply 2 by anything to make 11? No, we can't. So we're going to have to change both fractions. Multiply the first fraction by the second denominator, the 2, and the second fraction by the first denominator, the 11. 3 times 2 is 6, 11 times 2 is 22. So I've now got an equivalent fraction, and then I multiply my second fraction by 11. I've now got my common denominator, which is 22, and I simply add the tops. 6 add 11 is 17. Again, we can see we have to do the same method on the final question, so I'll times my first fraction by the 8 and my second fraction by the 9. So I get 32 over 72 plus 27 over 72. Again, we've now got our common denominator, so we're happy we can add those just as they are. So we end up with 59 over 72. Now, none of these fractions could actually be simplified, which is quite rare. So with the questions that I'm going to give you on the next slide, always just check, can you cancel down or simplify any of your answers? So the next part of this video then will be for you answering some of these questions similar to this. So when the questions appear, make sure you pause the video and answer the questions. And as always, once you've finished, if you press play again, I'll then go through the answers. Good luck! Okay, so if you've not finished these questions, please make sure you pause the video as I'm about to go through the answers. Okay, so for this first question, we can't do anything to the smaller denominator, the 4, to make it 11, so we're going to have to change both fractions. We'll do this by multiplying our first fraction by 4 and our second fraction by 11. So we end up with 8 over 44 add 11 over 44. You've now got a common denominator of 44, so you can just add the tops. 8 add 11 is 19. Okay, for the next one, we cannot do anything to 5 to multiply it up to 7, so we just times the whole of the first fraction by 7 and the whole of the second fraction by 5. Remember, we're multiplying by the denominator of your other fraction. By doing so, we get 21 over 35. Take away 10 over 35. Common denominator has been achieved, so we just take away 21, take away 10. So we get 11 over 35. Okay, this one here then, going to have to change both again, so you should have multiplied the first fraction by 3, the second fraction by 4, which would have given us 9 over 12, take away 4 over 12, which leaves us with 5/12. On the next one, you should have realised that you needed to multiply the first fraction by 8 and the second fraction by 9. This would give us 32 over 72 plus 63 over 72. Now we have the common denominator, we can just add them. And so we got 63 add 32, which is 95 over 72. Now what you'll notice here is that that's an improper fraction. It's bigger on the top than it is the bottom. So we should convert it into a mixed number. So how many times does 72 go into 95? And it goes in once. We then need to find the remainder. Now remember, you don't have to do this in your head. If you don't know what the remainder is, just do a little subtraction. 5 take away 2 is 3, 9 take away 7 is 2. So your remainder of 23 goes back over the denominator as 72. So your final answer for this one then is 1 and 23 over 72. Okay, for your final question, you should have multiplied the first fraction by 11 and the second fraction by 7. So we end up with 44 over 77 plus 14 over 77. And so then we can just add the tops, so we get 58 over 77. Okay, if you've got any of those wrong, it might be worth you just having a little look to see where you went wrong. And if you're still not confident, just replay the previous part of the lesson and try the questions again. This next part of the lesson teaches you to do something that we have actually spoken about in the previous parts of the lesson. And it's converting what we know as an improper fraction, otherwise known as a top-heavy fraction, into a mixed number. So a mixed number is mixed between whole numbers and fractions. Okay, so then, in order for us to convert this first one, this improper fraction, into a mixed number, we see how many times 7, the denominator, goes into the numerator 16. So how many times does 7 go into 16? We have 7, 14. So it goes in twice. So that's our whole number. So 7, 14. We're at 14, but we got 16, which means we have 2 left over. The remainder 2 goes back over the same denominator of 7. So let's try this one here. How many 4s go into 13? So we have 4, 8, 12. So it goes in 3 times. Now if we're at 12 and we actually had 13, it means we have a remainder of 1. So that remainder goes back over the denominator of 4. So that's the same as 3 1/4. This one here. How many times does 10 go into 49? 10, 20, 30, 40. So it goes in 4 times. We got to 40, so there was a remainder of 9. That remainder goes back over the 10, so it's 4 9/10. This one here. How many 5s go into 27? 5, 10, 15, 20, 25. So it goes in 5 whole times. The remainder is 2. To get from 25 to 27 was 2. And it goes back over the same denominator, so 5 2/5. This one here, how many 10s go into 100? Well, that just goes in 10 whole times. There are no remainders, so this is a whole number, just 10. How many times does 20 go into 107? 20, 40, 60, 80, 100. So it goes in 5 times. And if we're at 100 and we have 107, we've got 7 left over. and it goes over the 20, so 5 and 7/20. Okay, so I'm about to go through the answers, so if you've not finished, please make sure you press pause now. So for this one, 5 goes into 37 7 times with a remainder of 2. So your first answer was 7 and 2/5. 4 goes into 29 7 times with 1 left over, so it's 7 1/4. 2 goes into 17 8 times, and there's 1 left over, so that becomes 8 1/2. 8 goes into 24 3 whole times with nothing left over. 10 goes into 17 once with 7 left over, so that becomes 1 7/10. 20 goes into 49 twice with a remainder of 9, so you end up with 2 9/20. In this part of the lesson, we're going to learn how to do the opposite of what we've just done. So we're going to convert mixed numbers into improper fractions. So what you do here, you do your whole number, your integer, multiplied by the denominator, and then we add on the numerator. So we do 1 times 5 is 5, and then we add on the 4 to that. So 5 add 4 is 9. Now that 9 goes back over the same denominator, which is the 5. So let's have a look at the next one. We do 3 times 9 is 27. 27 add 2 is 29. And it goes back over the 9. And then this last one here, 10 times 2 is 20. 20 add 1 is 21 over the 2. So again, as always, I'm going to give you a few questions for you to try. So when the questions come up, make sure you pause the video and give them a try before pressing play again. Okay, so now I'm going to go through the answers. So if you've not done them yet, please make sure you pause the video now. So for the first question, 3 times 5 is 15. 15 add 2 is 17, so you would have got 17 over 5. 7 times 9 is 63. Add on the 4 is 67, and you pop it back over the denominator 9. 10 times 4 is 40. Add the 1 is 41 over 4. 6 times 5 is 30. 30 add 4 is 34, and you pop it back over the 5. 2 times 7 is 14. 14 add the 3 is 17, and it goes back over the 7. And then finally, 1 times 20 is 20. 20 add the number on the top, the 1, is 21, and you pop it back over the 20. Now if there was any question there that you got wrong, I suggest you just replay the video before and then try and do these questions again. Okay everybody, well done on getting this far. You're now on the last part of this fractions lesson. So we've learned all of the skills that we need to know to be able to answer these 4 questions here. We now know how to add, subtract, times and divide fractions, and we know how to convert between mixed numbers and improper fractions. So this skill is needed in the Year 6 SATS papers and is also needed all the way up to Year 11 and frequently occurs in the GCSE papers. So if you have something with a mixed number, in order for us to do a sum with the mixed number and the fraction, you're going to need to change it into an improper fraction. So what we'll do first is we'll change 2 1/3 into an improper fraction. So 2 times 3 is 6, add the 1 is 7. So this here becomes 7 over 3. And then we'll keep the second one the same, times by 3/4. Now if you think back to the first part of this lesson, when we multiply fractions, So nice and easy, we just multiply the numerators. 7 times 3 is 21, and then 3 times 4 is 12. I'm going to cancel this down before I convert it into a mixed number, because I can see that 3 goes into both. So if I divide the top and the bottom by 3, I got 7 over 4. Now that is an improper fraction, so if you get a question like this that ends up improper, you'll probably be asked to leave it as a mixed number and you'll be awarded more marks to do that. So how many 4s go into 7? 1 with a remainder of 3. So our answer here is 1 3/4. So the addition and the subtraction, in my opinion, are two of the most difficult questions to be able to do with mixed numbers, because there's a lot of work to it. So what we'll do first is we will convert them both into improper fractions. So 1 times 5 is 5, 5 add 3 is 8. So we have 8 over 5 plus 2 times 2 is 4, add the 1 is 5 over the 2. Now again, we know from the previous parts of this lesson that when we add and subtract fractions, we need the same denominator. So I can't multiply the 2 by anything to make the 5, so I'm going to have to change both of these fractions. I'll multiply my first fraction by 2 and my second fraction by 5. Remember, we multiply the first fraction by the second denominator and the second fraction by the first denominator. So I get 16 over 10, so these two are equivalent here, plus 25 over 10. Now we've got a common denominator, which is 10, we can add them together. So 16 add 25 is 41, so I get 41 over 10. Again, in this case we have an improper fraction, or otherwise known as top heavy, so we can convert it back to a mixed number. So how many 10s go into 41? That would be 4. What's left over? 1. So our answer is 4 1/10. Okay, on to the question with the division. Again, we're going to change this mixed number into an improper fraction. 3 times 2 is 6, 6 add 1 is 7. So it becomes 7 over 2, and then we divide it by 1/4. Now remember, when we divide fractions, we don't actually divide, we turn it into a multiply by crossing through and multiplying across the diagonals. So I'm going to do 7 times 4 is 28, and 2 times 1 is 2. Again, it's improper, and actually here 28 can be divided by 2 completely. So 28 divided by 2 is 14, and that's our answer for that one there. Okay, and the last question, so the subtraction is quite similar to the addition, where there's quite a lot of steps to this. So we're going to change them both again. 3 times 3 is 9, add the 1 is 10, so I get 10 over 3, subtract 1 times 7 is 7, add the 5 is 12. Again, we don't have the same denominator, and unfortunately I can't do anything to 3 to make it 7. So again, I'm going to have to change both of my fractions in this case. So I times the first fraction by the second denominator, the 7. And I times the second fraction by the first denominator, which is the 3. So this fraction here becomes 70 over 21. And the second fraction becomes 36 over 21. Now we'll do the subtraction. 70 take away 36 is 34, and the bottom stays the same. Again, we have another improper fraction. This won't always be the case, but in all 4 of the questions I've done here it was, so we convert it back into a mixed number. So how many times does 21 go into 34? It would be once, with a remainder of 13, and that 13 goes back over the 21. So these questions are really quite tricky. As I said, you do need to know them even in year 11 for your GCSEs. So what I suggest is that if any of that was unclear, or if you would like to rewatch this video, I would do that again before answering the questions. So on the next slide, you're going to have 4 questions: 1 add, 1 subtract, 1 times and 1 divide, and they're going to be very similar to this. If you end up with an answer like these, where they were improper, I would expect you to convert them back to a mixed number. So for some exam boards, this type of question here could be worth up to 4 marks. Okay, good luck. Okay, so I'm going to go through your answers now to the questions that you've just done. For the first question, you want to convert this mixed number into an improper fraction. So this would become 9 over 2, and then we're going to multiply it by 1/4. Now when we multiply fractions, remember we just times the top together, so 9 times 1 is 9, and then times the bottom to give us 8. Because it's improper, we need to put that back into a mixed number. So how many times does 8 go into 9? 1, with a remainder of 1, which goes back over the 8. For the next question, quite a tricky one. Again, we're going to convert both of these mixed numbers into improper fractions. So the first one would have been 11 over 3. 3 times 3 is 9, 9 add 2 is 11. The second fraction, 2 times 2 is 4, add the 1 is 5, so it becomes 5 over 2. So in order for us to be able to subtract these fractions, we know that we need a common denominator. So we're going to times the first fraction by 2 and the second fraction by 3. Now this gives us 22 over 6 for the first fraction and 15 over 6 for the second fraction. Now that we've got a common denominator, we can subtract them, so 22 take away 15 is 7. Again, because that's improper, we'll convert it back, which ends up being 1 and 1/6. Okay, so for the next question, we've got 2 mixed numbers again, so quite a lot of work for these questions here. So the first fraction becomes 5 over 2, and the second fraction becomes 5 over 4. Now remember, the method for dividing is to cross multiply, making sure we do that step on the top. 5 times 4 is 20, 2 times 5 is 10. Now if you have a look here, how many 10s go into 20? Your answer would have just been 2 wholes. Okay, and for the final question, we're going to convert this mixed number into an improper fraction. 1 times 6 is 6, add the 5 is 11. So we get 11 over 6 plus the 2 over 3. Now we know that when we add and subtract fractions, we need the same denominator. Now this one here can be multiplied by 2 in order for us to get a common denominator of 6. So we only needed to change one fraction in this case. So 11 over 6 add 4 over 6 is 15 over 6. Again, that is an improper fraction. So how many 6's go into 15? That would be 2. And then we've got 3 left over, and it goes back over the 6. Now in this case, we can even cancel down that final fraction to be 2 and 1/2. Okay, thank you very much for listening to this lesson, and I hope it was useful. If you've got any questions at all, please feel free to email me on the email address that is coming up on the slide next. Well done.